Hi everyone! In today's video I will show you the identity of Sophie Germain and solve a Math Olympiad problem using the identity. Now, since it wasn't common for women to do mathematics at the time she lived, she published all of her most important work under the name of Auguste Leblanc. But she did amazing work in all kinds of branches of mathematics, and she even impressed some really famous mathematicians like Lagrange and Gauss. So let's see what she discovered. She discovered that we can write the following as a squared plus 2b squared, and this whole thing squared, minus 4a squared b squared. Now this happens to be a difference of squares. So this is equal to a squared plus 2b squared minus 2ab times a squared plus 2b squared plus 2ab. And this is the identity of Sophie Germain. So a to the fourth plus 4b to the fourth is equal to a squared minus 2ab plus 2b squared times a squared plus 2ab plus 2b squared. A formula that you probably haven't seen in high school. But it is a really useful formula, since if these two aren't equal to 1, we can say that this isn't a prime number. So that every number of this form isn't a prime. So let's now use this identity to solve our Math Olympiad problem. To solve this problem, we need to calculate the value of p, which is this huge expression. So let's try to simplify this using the identity of Sophie Germain. Now notice that every factor is of the form with k a natural number of the form k to the fourth plus 1 over 4. And let's now try to get this into the form a to the fourth plus 4 times b to the fourth. Then it becomes k, that is our a value, to the power of 4 plus 4 times, and our b value happens to be 1 over 2. Since if we raise this to the fourth power, then it becomes 4 times 1 over 16, which is exactly 1 over 4. So now we can use the identity of Sophie Germain, which says that this is equal to a squared minus 2 times k times 1/2 plus 2 times 1/2 squared, and this whole factor times another factor, which is k squared plus 2 times k times 1/2 plus 2 times 1 over 2 squared. And we can simplify this even more by writing this as this just becomes a k. So it is k times k minus 1 plus 1/2 times k times k plus 1 plus a half. So now that we have found this factorization, we can split every one of these terms by using this factorization. But first, let's clear the board. So using this equality that we derived, we can now write this whole fraction as, first we use k equals 2. So that gives us 2 times 1 plus a half times 2 times 3 plus a half. Now let's substitute 4 into k. Now we get 4 times 3 plus a half times 4 times 5 plus a half. And this pattern will keep repeating until we have to plug in 100 for k, and then we get 100 times 99 plus a half times 100 times 101 plus a half. Now in the denominator, we will get the 1, so it will be 1 times 0 plus a half times 1 times 2 plus a half. Then the 3, which will give us 3 times 2 plus a half times 3 times 4 plus a half. And this all the way until we need to plug in 99 for k, and then we get 99 times 98 plus a half times 99 times 100 plus a half. But now notice what happened. A lot of factors appear in the numerator and in the denominator. So this factor cancels out with this factor. And this factor cancels with this one. And this pattern will keep repeating until the only thing that's left is this factor and this factor. So our huge fraction becomes an easy fraction, which is 100 times 101 plus a half divided by 1 over 2. Now let's multiply both sides by 2, so then we get 2 times 100 times 101 plus 1. And this is equal to 20,201. And that was exactly option D. So we solved our question